Good morning to all. I am T. Lingambupati, Assistant Professor, Mechanical Department, Pondicherry College of Engineering, Nagarkoil. Last class I taught you about a problem based on one of the mass transfer problem. Based on the isothermal evaporation of water into air. Right? In this class I am going to teach you about a problem based on the radiation heat transfer. First, we need to know what's by radiation. What's by radiation? Radiation is one of the mode of heat transfer. To transmit the heat from one body to another body. Without any medium. That is called as radiation. Right? This radiation takes place between different bodies without any medium. Right? Then this radiation we can measure with the help of different kinds. What are kinds means? First, wavelength, surface temperatures, right, and intensity. Wavelength, surface temperature, and intensity. According to these things, we can measure the radiation heat transfer. Takes, right? Then we need to know first the value of emissivity. What is my emissivity? Then only we can able to know the radiation. We can learn about radiation. The radiation means how much amount of heat emit, how much amount of heat transfer, how much amount of heat absorb. Right? All the things takes place. Absorption, reflection, otherwise transformation. Right? These three things happen in the radiation. I am going to consider a body. Right? In this body, I am going to give some energy. In inclined motion. That energy is Q. Right? From this energy, some amount of energy will transfer. Through this passage, QR. Otherwise, Q transfer, QT. Then, some amount of energy will reflect. That reflection should be in 90 degree. Most of the cases, the reflection should take place in 90 degree. Right? Then, some amount of energy absorbed by a body. This kind of things will happen in the radiation. Right? How will you get the inclined energy? Supplied energy. That Q is equal to QA plus QT plus QR. Right? Absorptivity, transformivity, and reflectivity. Right? When we know about these things, then only we can able to measure the amount of heat transfer. Takes place in this body. Right? These are the basic things we need to know. Then only we can able to know about the radiation. How we can measure the radiation? with the help of different laws. What are the laws we will use here? What are the laws means? First one, Planck's law. Planck's law. With the help of Planck's law, we can find the emissive power. We can find the emissive power. The formula for the Planck's law is the emissive power is equal to C1 lambda power minus 5 divided by lambda 2 divided by lambda t minus 1. From this equation we can find the value of emissive power. Then another equation will be there, another laws will be there, that is Wien's law. This is the displacement law. Wien's law is the displacement law. Then equation will be lambda max T is equal to 2898 micrometer Kelvin. The micrometer is a unit. 1 micrometer is equal to 1 to 10 power minus 6 meter. Right? 1 micrometer is equal to 1 to 10 power minus 6 meter. Right? These things we need to know, because all the problems we need to take this value from the HMD data book. This formula we need to take from the HMD data book. But in this HMD data book only available this formula. The Stefan-Boltzmann law. What's my Stefan-Boltzmann law? In this Stefan-Boltzmann law, the emissive power is directly proportional to the temperature power 4. Right? Then we can write the term in equation form. The Stefan-Boltzmann constant sigma T power 4. Here sigma is the Stefan-Boltzmann constant. T is the absolute temperature. The Stefan-Boltzmann constant is constant. The value is 5.67 into 10 power minus 8. 5.67 into 10 power minus 8 watt per meter square Kelvin. Kelvin power 4. Treat the problem. Assuming sun to be black body emitting radiation with maximum intensity at lambda is equal to 0.5 micrometer. Calculate its surface temperature and emissive power. First we need to understand the problem. Assuming the sun to be black body. So it's a black body problem. They given the black body. So and black body emitting radiation. So radiation comes under the radiation. Right? Black body radiation problem. Right? Then what are data given? They given the lambda value, it's equal to 0.10 micrometer. The given data, lambda is equal to the maximum intensity. So it's the lambda max. Is equal to 0.5 micrometer. We need to convert it into meter. 0.5 into 10 power minus 6 meter. Right? Then what are the other data given? No other data. Then what we need to find? temperature. Second one, emissive power. Total two data we need to find. How you can solve this problem? How you can solve this problem? Only one data is given, maximum intensity. Maximum intensity only given. How you can solve this? And find the value of temperature and emissive power. Yeah, we know the value of formula with the help of Wien's formula. Solution from HMD data book. Page number 90. Page number 90. We can write the formula for Wien's law. The formula for Wien's law, that is lambda max T is equal to 2898 micrometer Kelvin. Micrometer. Substitute all the values and find the value of temperature. The value is 5800 Kelvin. We found the first term. Right? Next, we need to find the second term, emissive power. How you can find the value of emissive power? How you can find the value of emissive power? How you can find the value of emissive power? With the help of Stefan-Boltzmann equation. With the help of Stefan-Boltzmann equation. That formula is available in the HMD data book. Page number 90. Page number 90. Right? What's the formula? The emissive power is equal to sigma T power 4. Sigma T power 4. Already the Stefan-Boltzmann constant. Sigma is the Stefan-Boltzmann constant. Stefan-Boltzmann constant. Right? The value is 5.67 10 power minus 8. 5.67 into 10 power minus 8 watt per meter square Kelvin power 4. Now we can substitute the value of Stefan-Boltzmann constant and temperature value and find the value of emissive power. What's the value of emissive power? 64.1 into 10 power 6 watt per meter square.